Oil mining, often called petroleum extraction, begins deep beneath the earth where hydrocarbons have been trapped for millions of years. These natural resources were formed from the remains of plants and marine organisms buried under layers of sediment and rock, gradually transformed by heat and pressure. Over time, these materials became oil and gas reservoirs, hidden beneath impermeable rock layers, waiting for humans to discover and extract them. The story of oil mining is not only about the resource itself, but also about human ingenuity, technology, and the economic importance that oil plays in the modern world. Drilling is the next critical step. Engineers use advanced drilling rigs that bore through layers of soil, rock, and shale to reach the oil reservoir. Modern drilling techniques allow for both vertical and horizontal drilling, maximizing efficiency. Drilling fluids, or mud, are circulated to cool the drill bit, stabilize the well, and carry rock cuttings to the surface. Safety measures are crucial because drilling too deep or without proper control can lead to blowouts or environmental disasters. Once the oil-bearing formation is reached, extraction begins. Pumping systems, such as pump jacks on land or subsea wells offshore, bring crude oil to the surface. In some cases, natural pressure pushes the oil upward, but often artificial lift methods like gas injection or water flooding are required. These techniques increase reservoir pressure, allowing more oil to flow out. This stage marks the beginning of full-scale production. Transportation infrastructure is a major part of oil mining. Pipelines stretch across continents, carrying millions of barrels daily, while oil tankers move it across oceans. Storage tanks and distribution hubs ensure steady supply to refineries and markets. This massive logistical network is the invisible backbone of global energy trade, ensuring oil can reach consumers wherever it is needed. 32. Despite its benefits, oil mining comes with environmental and social challenges. Oil spills, gas flaring, and land disruption harm ecosystems. Offshore drilling, especially in deep waters, poses risks of catastrophic spills. Moreover, the burning of oil-derived fuels contributes significantly to climate change, pushing governments and companies to consider renewable alternatives. Yet, oil remains deeply tied to economic growth and industrial development worldwide. Oil mining has also shaped geopolitics. Nations rich in petroleum reserves, like Saudi Arabia, Russia, and the United States, hold significant influence over global energy prices and international relations. The control of oil resources has sparked alliances, conflicts, and wars throughout history. Energy security remains a critical concern for governments as they balance reliance on oil with the need for stability and sustainability. Technological advances are helping reduce oil mining's negative impacts. Digital monitoring, automation, and cleaner extraction methods are making the process safer and more efficient. Enhanced oil recovery techniques and environmentally responsible practices aim to extend the life of oil fields while reducing carbon footprints. Research into carbon capture and storage is also being integrated into some oil operations. In conclusion, the story of oil mining is one of discovery, engineering, and global interconnection. From deep beneath the Earth's surface to the fuel pumps in our cities, oil travels through a complex chain of exploration, drilling, refining, and distribution. While its benefits are undeniable in powering industries and transportation, its challenges demand innovation and responsibility. Oil mining stands as a symbol of both human achievement and the urgent need to balance energy demand with environmental stewardship for a sustainable future. The story of oil mining, often referred to as oil extraction, is one of mankind's most ambitious industrial endeavors that begins deep beneath the Earth's crust and extends all the way to fueling global economies, starting with the identification of potential reserves through geological surveys where scientists, engineers, and geologists study rock formations, seismic data, and historical records of petroleum deposits to locate areas where crude oil may lie trapped beneath layers of sedimentary rock. And once these sites are identified, teams move in to conduct test drilling and exploratory wells, using advanced seismic imaging, satellite data, and geophysical instruments to reduce uncertainty, and if significant reserves are discovered, a massive project unfolds to establish drilling operations, which typically begin with clearing the land, building access roads, and setting up rigs capable of drilling thousands of feet into the earth. Then workers sink a drill bit attached to a drill string, lubricated and cooled with drilling mud that also carries rock cuttings to the surface, while steel casing is cemented into place to stabilize the borehole and prevent collapse or contamination of groundwater. And once the drill penetrates the reservoir rock containing hydrocarbons, engineers carefully monitor pressure and flow to control the release of oil and gas, using blowout preventers to avoid dangerous uncontrolled eruptions, and depending on the geology of the reservoir. Extraction may begin naturally if underground pressure is sufficient to push oil to the surface, or artificial lift techniques such as pump jacks, gas lift, or submersible pumps may be installed to aid recovery, while in more advanced projects, secondary and tertiary recovery techniques like water flooding, steam injection, or chemical flooding are employed to maximize output, and as oil reaches the surface, it is separated from associated gas, water, and sediments through separators before being